All right, we're going back to this bar pie chart frequency histogram file. And it's in My Open Math. All right, and we were on the frequency tab. And we calculated relative frequency. Relative frequency is just the percent or the proportion in each class. Take the frequency equals, click on the cell, divide, and click on the total. And we're going to copy this cell down, but we have to lock the cell reference for the total. To lock a cell reference, put a $sign in the front of the row and column. So $D and then $12. And you can lock the row but not the column but not the row. This locks them both. So no matter where you copy this cell, it will have that as its address. So once that's copied, then we can just pull it down. There's at least 3 ways to do everything in Excel. And we want to copy this down. If you go to the little square on the back, on the bottom right corner, and double click, it will fill in to match whatever is in this column. Or if you go to that cell, get the cross, then push the left mouse button down and pull it, it'll copy it. Or you can copy the cell, then mark the others and say paste. So any one of these will do. Relative frequency has to add to 1. So we need to make sure it adds to 1. Up on the far right is a sigma, Greek letter S. And these are automatic commands. If you press on that arrow there, these are the things it will do automatically. Average, count, max, min, and there's more. But we want just the sum. So if we're at the bottom of a list and you do sum, it will automatically set up the sum for all of those things in that list above it. And it adds to 1. Relative frequency. So about 29% are red, 22 are blue, and so on. I'm going to take some decimals off of this. I'm going to mark my numbers, and if you go to this spot right here and click on the little arrow, you will get formats for numbers. We want a number, and we just want 2 decimal places. You can specify the number of decimal places. You can cut them off entirely. But automatically it uses 2. And one of the problems with Excel is that it will give you answers to literally 13, 14 decimal places, which is completely idiotic. There's no reason for that kind of accuracy because you don't have that kind of accuracy. It just makes you think so. Cumulative frequency, we're going to add the frequencies. So the first is going to be 23. The next one's going to be 23 plus 18. The next one, 23 plus 18 plus 9, and so on. And there's an easy way to do this. Do equals and click on the first one. And I don't know why it's got small numbers. Go to the next one down, do equals, then click on the top one, on the 23 we just put in there, plus, then click on the 18. In this cell, it's set up so that whatever is here plus that goes into there. So if we copy this down, this plus that will go into there, and on and on. So it's a cheap trick, but it works. And I got 160 because I counted the 80 twice. Cumulative relative frequency is the same thing, except it's for relative frequency. So this equals the 0.29. Then in that cell equals the 0.29 plus 0.23. And now if I copy that down, I get the rest of them. Because I'm adding successive cells. So this plus that goes there, that plus that goes there, and on down. So this is a way to look at what percent are in categories. Like half of them are red and blue. One thing with this one, though, is that there's no natural order to these colors. It's red, blue, black, green, white. It could be completely the opposite, or some other combination. There's no implied order in these things. They're just names. But that's how you do the frequency, cumulative frequency, relative frequency, and cumulative relative frequency. And if you have any one of them, you can get all of the others. So I can go back from this to this, and if I know the total, I can get all the rest of this. So they're all some version of the same thing. Let's make a chart. We're going to make a histogram, or excuse me, a bar chart for the colors using the cumulative relative frequency. And if we did it for cumulative frequency, it would look the same, just the y-axis would be scaled differently. Mark that column, go to Insert, and then back to Charts, and we want bar chart. And I'll erase the title. We don't need a title. Here's the chart, and it shows these successively. This is a nice smooth line. It's cumulative. It adds up to the total. And if I want to change the x-axis titles, right-click in the graph, select data. There's also a select data up at the top. It's exactly the same select data. It's just a different spot for it. I have my series, and if I look at this, it's the list of numbers I've got. I want to edit the x-axis categories, x-axis labels, and for this, I just mark the colored names, And there is the cumulative frequency for red, blue, black, green, white. Once you can do one kind of chart, they're all the same. Anything you want to change on this, the color, is exactly the same on all the different types of graphs that you can have. So once you got one, you got them all. Now we're going to go to a histogram. This is the next tab on the page. And this is the cubic feet per second of the new river at Radford for the water monitoring. So this is just 17 days worth of data. And this is cubic feet per second, and it has a ratio scale. This isn't like color. There's a pattern to this. It's got a real zero. It goes up and down, and I can give it a name. I can say this is more than that. I can't say green is more than red. But here, 2,900 is more than 2,200. So this is called a histogram. It's just a frequency using a probability scale, a real scale that I can use. This is a probability distribution. So I'm going to make a frequency table using these values. To do this, we have to have limits, class limits. What are we going to put in each class? For this one, the first class that I've got here is 1,001 to 1,500. The next class is 1,501 to 2,000. The only deal with this is they can't overlap and there can't be any holes. In this one, I have decimals in some of these places. So I need class boundaries as well. The class limits are kind of the public table that you're going to show people. The class boundaries are the dividing lines between the classes. So that this one, I've got from 1,000.6 to 1,500.5. And that will split all of the things I got here into one of these classes, regardless of what the number is. If it's got a decimal, I got it covered. And I can use any class boundaries I want. I could do 1,000.9 to 1,500.1, as long as I don't have a gap. And there's a lot of stuff about how many classes to use and what the boundaries ought to be and all kinds of nonsense. Most class boundaries suggest themselves. You can get into a lot of stuff. Generally, between 5 and 12 classes is enough. 12, more than 12, it's just unwieldy. Fewer than 5, you aren't getting any separation. So class boundaries and limits suggest themselves by the subject. So rather than look at some kind of algorithm to find those things, just do the obvious. Some people say, oh, get the range from smallest to largest, divide by the number of classes, and so on. And then you end up with classes like 1,001 to 1,257. And the next one is 1,258 to something else. Just do the obvious when you're doing class boundaries. The limits are the ones that we show people. The boundaries are the edges. Each of these is 1,000 wide. 1,500 wide. 500 wide. What is it? 500? you want all the boundaries, all the widths to be the same. If you see a chart or a histogram, a frequency distribution, and the boundaries are not equal between classes, someone is lying to you. And of course, nobody would do this. Here is, from Fox News, a COVID graph showing number of cases. And if you look close, starts at 30, goes to 60, goes to 90, goes to a 100. 30, 30, 10, 30, 30, 30, 50, 50, 50, 50. So that this scale is distorted. What they were doing in this graph is making this jump from here to here look smaller. They didn't want to show how many. It really doesn't make a difference because the graph shows pretty much what it shows. But if you see something that has unequal intervals, someone is making it up. This happens, it's common, and that's just the way it is, and that's what you got to look out for. Now we're going to do frequency for these. And in Excel, all you need is the upper boundary. This boundary right here is going to be our limits. Anything that's less than 1500.5 goes into the class below. Anything from 15.5 to 2000.5 goes into that one. These are the upper limits, and these are called bins in Excel. I'm going to copy these values and put them over here so I don't get things in the way. Copy, and I'm going to go over here and paste. And here, I don't have calculations in here, so I can just do paste. And it will take whatever's in here and paste it over there. If these cells were calculated, and I copied them, it would try to maintain that calculation with the relative position of the numbers. So here's my list. These are the bins. And before Excel, nobody called them bins. They were just the limits. Come on. I want bigger numbers, guys. Now I'm going to mark from here to here, all the way down that list. I got it marked. Now I'm going to start typing equals and FREQ, or FRE, and it looks up what commands it's got that start with FRE, and the only one is frequency. So I've got frequency. I'm going to double click on that, or you can type it out. And it puts in frequency and opens a parenthesis for you. The first thing it wants is the data array. And here's our data over here. We're going to mark this entire column as the data array. So my data array is D5 to D21, comma, and then it wants the bins array. That's my values here. So I have data marked, comma, and then the bins array. close the parenthesis, got a little extra there, and enter. Excel always thinks you're an idiot, and you may be. I've done some pretty stupid things. But it's looking out for you, and it wants to help. Particularly with this AI stuff, they got, oh, I can do that better than you can. Look. And it put in an extra 0 down here. This is the spot where it would put anything that didn't fit in what I had. And it will tell me that. That would be anything that was greater than 7,000.5 would be down in here. So here's my frequencies, and right here, 0, 4, 5, 3, 2, I can take these, copy them, and stick them in here, except they're already in there, so I don't need to do that. But now I've got frequency, and that's how you calculate frequency. There's another command that does the same thing, but for this one, the bins and the numbers, the frequencies, have to be next to each other. The data can be elsewhere. But for this, bins and frequency, if you're going to calculate it, has to be together. Next thing I have here is midpoints. And these represent the class. I need a midpoint. I need something that represents 1,000 to 1,500. And again, there's lots of advice. You're supposed to average the upper limits or average the lower limits or do all kinds of stuff. Find something that looks like it's in the middle and use it. Don't do anything exotic. Like here, this 1251, this is the average of G6 and H6, the upper successive lower limits. This is one of the suggestions. I have got the average of the successive lower limits, and it comes up to be 1251. Why? 1250 is perfectly good. I have another candidate if I use a different algorithm that's suggested for class limits and midpoints. Don't do it. If you do the official calculations and it comes up like that, make it 1250. Because again, if you see somebody's numbers and they've got 1250.23, somebody screwed up. They don't know what they're doing. A class midpoint just has to represent the class. And these are as good as any. So rather than use a particular algorithm, use whatever you want, look it up, and then do what's the easiest and most obvious change from that. Right? Part of statistics is this is crap. And the sooner you can see this is crap, the better off you'll be. So anything strange, anything that looks exotic, it's crap. Here's my midpoints. I can use this to take the frequency, do the relative frequency, cumulative relative frequency, everything I did before, but now I've got it in a statistical distribution. I've got an interval or a ratio scale, not just colors and names. I've got an actual progression, and I've got the frequency with which those occur. So I have a probability distribution. The frequencies here have to add to however many I had. If I did relative frequencies, they would have to add to 1. So if I go here and do the sum, I don't know what it didn't like about that, equals sum, I think because I copied over the frequency distribution. There's 17. For this to be a valid frequency, these things have to add to 1 in the relative frequency or to the total in the frequencies. Okay, so that's a histogram. And this, I can make a bar chart and now I have some kind of meaningful scale on the bottom, and I could copy the midpoints to put in on this scale to make it look like something. But what does this say about the amount of water that comes through? Where's most of the flow? I'll put this on the scale. Select data. I'm just going to put in the categories using the midpoints. That's frequency, relative frequency, cumulative relative frequency. A histogram, this is a statistical distribution. This is the first one we've got. And that's how it's all calculated and all that goes into it. All right, we're going to go to the next topic. And for this, we need to go back to MyOpenMath. And here, we want measures of central location. This is the fancy term for where's the middle. So back to MyOpenMath, measures of central location, and the data we want this time is the fish length and weight. And this is fish length and weight, length in centimeters and weight in grams. And these are just fish. Here is 30 observations. And central location is like the average, the mean. That's the main one that's used. So we're going to calculate the averages for these things. Go to the length. This is the first one. And we've got commands for min, max, mean, median. What we want here is the mean, and we'll get the others. So we're going to have to do this the hard way. We aren't at the end of the list. So here, do equals. Come on, equals. I already did it. And then average. A-V-E-R. And as you type it, it will bring up all the possibilities. And we just want average. They have different averages. It will look at only non-blank cells. It will look at only cells that have a number in them, all kinds of things. We just want average. Double click. And then block off all of those lengths. Close the parenthesis, and there's the average. Average is the mean. An average, now, this is the middle value. Add them up and divide by however many there are. That's the average. You know how to calculate an average. Well, this is a sample average. The sample size is 30. And I am using this, if I want to represent this population of fish, of this particular sort in this particular area. Somebody says, how long are they? I say, well, they're about 36 centimeters long. So the average is a calculation, but it's also a characterization. It's a name. It's like, how tall are basketball players compared to the people in this room? They're taller. We're shorter. Right? That's like the average. The average could be 7'4" versus 6 foot. So we have a name for things. So an average is not just a number, it's a characterization. Something that I can call these things. And if you go and look at the My Open Math again, the population mean is called mu, Greek letter M. The sample mean is called X bar. That's an X with a line over the top of it. There's no good reason for either one of these. This is just the way they do it. So my sample mean, X bar, is add them all up, divide by how many there are. Population mean is add them all up and divide by how many there are. The problem is, I'll never know this one. All I've got is this, and I use this to estimate that. So those are the formulas, but everybody knows what the formulas are. You know how to get it anyway. Another number that I can use is the median. And the median is literally the middle value. If I put all of these numbers in a list and find which one's in the middle, that's the median. Like if I have the numbers 1, 3, and 9, what's in the middle? 3. But the average is different. 1, 3, and 9, 10, 13, and divide it by 3, it's more than 4. But if I had 1, 3, and 100, the average goes way up. What happens to the median? It's still 3. It's the middle number. The median is something that is actually every bit as useful as the average, but we couldn't calculate it easily until we had a computer. So that it got left behind long ago. And anything we do with the mean, we can do with the median. The median is a non-parametric measure. The sample average, I assume it has some kind of distribution behind it. The median, it's just in the middle. I got a high-low list, and I go to the middle. If I have 3 observations, or an odd number of observations, the median is the number in the middle. If I have an even number, I don't have a clean middle. Say I got 10. Whatever is at 5 and 6 position, averaged is the median. So here I've got 30. I'm going to copy these over. Home, copy, pick a spot, paste. And there's the numbers. Now, I've got these. I'm going to mark them. I had them marked. And then go to the top, and there is sort and filter. I can sort from smallest to largest, largest to smallest, or custom sort. With a custom sort, I have several columns that are tied together, and I want to sort them on one of those columns. We'll get to one of those, but right now we just need smallest to largest. And there's the smallest, 12.7. And where's the median here? With 30 observations, what's in the middle? 15, from 1 to 15, and then 16 to 30. I need the number in the middle, as many above as below. So if I go to 15 and 16, I would average these two. They're the same number here, which is convenient. So the median here is 35.6. It's literally the number in the middle. Suppose these are house prices in hundreds of thousands of dollars. If I toss in Bill Gates' house here at the end for number 31, and his house, I assume, is in the multi-millions of dollars, what happens to the average? It goes way up. What happens to the median? It doesn't move. The median is called resistant because it doesn't blow up like the average. And this is one advantage of the median. If I have some extreme observations, the median doesn't care. It's not going to go chasing after big numbers. I can get the median using one of the commands. This is equals, and I'm in the median spot here. MED, and there's median. Double click, and then mark the numbers that I want. Close the parentheses, and there is the official calculation for the median, which in this case is exactly the same as what I got out of the list. These things are characterizations. Here, the mean and the median are pretty much the same. That means that there's no weirdness in here. There's no really, really big or really, really small observations. By looking at the ratio or the difference between the mean and the median, I get an idea of how things are stacked up. There's nothing weird about it. There's Bill Gates' house is not in here. There's not a sailfish stuck at the end of this list. So those two things are what characterize the median, or the sample. And if I have these two, and I go to the bottom corner and drag them over, it will copy the calculation and get it for the weight. How's this look? Here's the average, is 323. The median is 337. What's the relative position of these things? The mean is here. The median's up here. What does that say about the observations? What would make the average less than the median? A bunch of really small numbers. So, looking at those things, you get an idea of what the layout is between these two things. All right, I'm going to mention this. This is the mode. They always throw in the mode. The mode is the number that occurs the most. That's it. And it's pretty useless. If I have a multimodal distribution, it means it's got high spots, more than one. Think of a bell-shaped curve, normal distribution. How many high spots has it got? Just one. If I stuck two of them together, it could go up, down, then back up again. And I have two high spots. So the mode is something that can tell you this is really strange if you've got a lot of modes in there because it's going like this. And that makes it unpredictable. But basically the mode is not used for anything. Equals mode. And it will calculate one, if there is one. $15.2. If I look at this, the sorted list, there's 15.2. It occurs 1, 2, 3, 4, 5 times. Nothing else occurs 5 times. So the mode is just the low one. But remember, the low average, this is what's pulling down the average, the numbers on the far end. So the mode does give you something in that, but for the most part, it's not particularly useful.